Hello students, myself Dr. Ahmed. I welcome you all to the 23rd lecture of Mathematics 2. Students, in the previous lecture, we have started rules for finding particular integral, right? Suppose I am given an equation, I am given a differential equation which is of this form, where d power n plus a1 into d power n minus 1 plus a2 into d power n minus 2 and so on an into y equals to x, right? Suppose the given equation is of this form, which is a nth order, means higher order differential equation with constant coefficients, and it is non-homogeneous because right hand side some function of x is there, right? This can be written in the form of f of d into y equals to 0, where f of d is this operator, nth order derivative operator, right? Since yp is particular integral, actually the solution of this equation will be having two parts. One is complementary function, that is the solution of homogeneous part. Right hand side we have to consider 0 and find the solution, that is called as complementary function, and it is denoted by yc. Right hand side, whatever the function is given, if that is considered, and we have to find the solution, that is called as particular integral. So the final solution y will be the combination of yc plus yp, complementary function plus particular integral. For finding complementary function, we need to depend on the auxiliary equation. We have to write the auxiliary equation, which is f of m equals to 0. This d should be replaced with m, f of m equals to 0, and solve that. So we will be getting roots for auxiliary equation. If the roots are real and distinct, if the roots are real and equal, if the roots are complex. On these three cases, there are three rules for writing complementary function that was discussed in lecture 21, right? In lecture 22, we have started rules for finding particular integral. This topic was started in the previous class, and we have considered the first case for finding, case 1 for finding particular integral, where the function x was considered to be, the function x was e power ax. If the function x is of the form e power ax, then how to find the particular integral, that we have seen in the previous class in lecture 22. Now in today's class, we will consider the case where x, right hand side function x, will be given as sine of ax plus b or cos of ax plus b, where a and b are constants, right? Sine 2x plus 3 or cos 5x plus 6 or cos 4x plus 2. If this is the form in right hand side, then how to find the particular integral, that we are going to discuss now. Okay, if right hand side x is given by sine of ax plus b or cos of ax plus b, then particular integral yp is given by yp equals to 1 by f of d x. X is nothing but here sine of ax plus b or cos of ax plus b, right? Sometimes b may be 0. If b is 0, then sine 1x, sine 2x, sine 3x, sine 4x, like that, or else sine 4x plus 2, like that the cases may be. A, b are constants here, right? If x is of this form, then particular integral is given by like this, and what we have to do now, write f of d as f of d square, means wherever d is there, try to make that as d square. Then what will happen, yp equals to 1 by f of d square. We are writing f of d as f of d square, then sine of ax plus b or cos of ax plus b. If cos is given, we have to consider only cos. If sine is given in right hand side, we have to consider only sine. Right, now replace d square with minus a square. Then what will happen, yp equals to 1 by f of minus a square into sine of ax plus b or cos of ax plus b, provided f of minus a square is not equal to 0. right, provided this condition f of minus a square is not equal to 0. If this is not equal to 0, then particular integral in case of x is sine or cos, in that case yp particular integral is given by 1 by f of minus a square sine of ax plus b or cos of ax plus b, provided this f of minus a square is not equal to 0. Suppose this f of minus a square is 0. If f of minus a square is 0, then what will happen? Then particular integral yp is, what we have to do? We have to multiply the numerator with x. We have to multiply the numerator with x and differentiate the denominator f dash of minus a square of sine of ax plus b or cos of ax plus b, provided again we have to write this, provided f of minus a square is, f dash of minus a square is not equal to 0. This should be not equal to 0. So this is the procedure to find particular integral when the right hand side function is given in terms of sine of ax plus b or cos of ax plus b. Let us understand once again what we have to do. If the right hand side function is sine of ax plus b or cos of ax plus b, what we have to do? We have to write this f of d in particular integral. While finding the particular integral, this f of d should be written in the form of f of d square. Then this f of d square, this d square should be replaced with minus a square. D square should be replaced with minus a square. It is not minus a whole square. It is not like this, minus a whole square. It is not like this, right? It is minus into a square. So d square will be replaced with f of minus a square, and this will be the particular integral. This will be the particular integral provided f of minus a square is not equal to 0. Suppose if this f of minus a square is becoming 0, then what we have to do? We have to multiply the numerator with x and differentiate the denominator. Multiply the numerator with x and differentiate the denominator. This will be the particular integral, right? Suppose again if this f dash of minus a square is becoming 0, then what we have to do? Again multiply the numerator with x. So we will get x square here and denominator will be f double dash of minus a square. Sine of ax plus b or cos of ax plus b will be as it is, right? So this is the procedure. Now let us see problems related to this. Okay, the first question is solve d square minus d minus 2 into y equals to sine 2x. So this is the given differential equation of second order. Right hand side sine 2x is given, so it's a non-homogeneous second order differential equation with constant coefficients, right? This question, this type of questions belong to, because it's a higher order differential equation, d square is there, higher order derivative is there. So this question belongs to unit 3, not unit 2. For unit 2, how to identify unit 2 problems? Differential equations will be of first order, right? If the differential equations are of higher order, then we have to clearly understand that those problems are related to second unit, right? Third unit, sorry. If differential equation is of higher order, then problem is related to third unit, right? So this is the given differential equation. As I told you, if the equation is non-homogeneous, then we have to find two things here. One is complementary function, another one is particular integral. So for finding first complementary function, we have to write the auxiliary equation. So auxiliary equation of 1 is given by f of m equals to m square minus m minus 2 equal to 0. F of m equals to 0. Then solve this. For solving this, we need to make factors. So m square minus 2m plus m minus 2 equal to 0, right? So further you take m common, then m minus 2 will remain here. You take 1 common, then m minus 2 will remain here. Then you take m minus 2 common. Let us take m minus 2 common. Then what will remain? M plus 1 will remain, which is equal to 0. Then what will be the roots from this? We will get the roots to be minus 1 comma 2. The roots are minus 1 comma 2. If the roots are real and distinct of auxiliary equation, then the complementary function for the given differential equation is given by yc equals to c1 into e power m1 x minus x plus c2 into e power second root x. Second root is m2, that is 2x. c2 e power 2x. Right, this is the complementary function we got. Now let us move for finding particular integral. Now for finding particular integral, what we have to do? Yp equals to 1 by f of d. F of d is given by, what is f of d? F of d is d square minus d minus 2, which is this d square minus d minus 2 into x, capital X. Capital X is here sin 2x, sin 2x. Right? Next, what we have to do, wherever d square is there, that should be replaced with minus a square, minus 2 square. D square should be replaced with, therefore, what will happen? Yp equals to 1 by, this d square should be replaced. This d square should be replaced with minus a square. A is 2 here. So, minus 2 square, then minus d. This minus d will be as it is. This minus d will be as it is. Then minus 2 into sin 2x. Right? Then simplify this. What will happen? 1 by, you see here minus 4 we will get here and minus 2. So, minus 4 minus 2 is minus 6 minus d into sin 2x. Now, here we are having d. In the procedure I told you that wherever d is there, try to make that as d square. For making this as d square, let us rationalize this. For making this d as d square, what we are going to do? We will rationalize this. So, minus 6 plus d, and here also minus 6 plus d into sin 2x. We are multiplying and dividing with minus 6 plus d. Then what will happen? In the numerator we will get minus 6 plus d, but the denominator will become, this is in the form of a minus b into a plus b. So, what we will get here? A square minus b square. So, minus 6 whole square is 36 minus d square we will get, right, into sin 2x. Further, minus 6 plus d by 36 minus, so now again d square should be replaced with minus a square, which is d square is replaced with minus 2 square. So, minus 2 square into sin 2x. So, further what will happen? Minus 6 plus d by here 36 minus minus will become plus, 2 square is 4. So, 40 we will get, 40 into sin 2x. Right. Further simplify, what we will get? 1 by 40 as it is we can write, 1 by 40 as it is we can write, then minus 6, multiply this, minus 6 into sin 2x, minus 6 into sin 2x, then plus d into sin 2x, derivative of sin 2x, derivative of sin 2x. What we will get? Derivative of sin is cos 2x into derivative of 2x is 2, right. So, 2 cos 2x we will get. If we simplify further this, then what will happen? We can take 2 outside. See, from this if we take 2 outside, minus 3 will remain here and this 2 will be taken out. 2 by 40, which is 1 by 20 into minus 3 sin 2x plus cos 2x. Right, this is the particular integral. Then what will be the final solution? Therefore, final solution is y equals to, therefore, general solution y equals to yc plus yp, which is, what is yc? Yc is given by this c1 e power minus x plus c2 e power 2x plus 1 by 20 into minus 3 sin 2x plus cos 2x. Right, this is the required general solution of the given equation d square minus d minus 2 into y equals to sin 2x. What is the procedure? First we have to find the complementary function by writing the auxiliary equation and finding the roots. Then we have to consider the particular integral. If the right hand side function is sin ax plus b, that is sin 2x, sin 3x, sin 4x, or cos 2x, cos 3x, cos 4x, d square should be replaced with minus a square. Then we have to rationalize to get d square. So, this is the procedure we have to follow, right. We will see one more problem where the failure case may rise, right, that is the denominator becomes 0. We will consider the second problem. Second question is, solve d square plus 4 into y equal to sin 2x. Right, consider the given equation as equation 1. So, again what we have to do? First we have to find the complementary function, because it's a non-homogeneous equation. Complementary function we have to find and particular integral also we have to find. For finding complementary function, we have to write the auxiliary equation. So auxiliary equation is, what is the auxiliary equation here? M square plus 4 equal to 0. Then m square equal to minus 4, right? M square equals to minus 4. Then m equals to plus or minus square root of 4 is 2, square root of 4 is 2, and square root of minus 1 is I. So what we are getting here, m equals to plus or minus 2i. What kind of roots we are getting here? It is in the form of 0 plus or minus 2i. It is in the form of alpha plus or minus I beta, right? Complex roots. For complex roots, what will be the complementary function? Yc equals to e power alpha x. Alpha is 0 here. So e power 0x into c1 cos beta x. Beta is 2 here. c1 cos 2x plus c2 sin 2x. Right, this will be the complementary function, because e power 0 is 1, so this can be written as, complementary function can be written as yc equals to c1 cos 2x plus c2 sin 2x. This is the complementary function we got. Now move for finding particular integral. So now particular integral equals to, what it is? Yp equal to 1 by f of d. F of d, 1 by f of d. F of d is d square plus 4 into x. X is here, capital X is here, sin 2x. Now what we have to do? See, it is in the form of d square only. So d square should be replaced with minus a square. When we replace d square with minus a square, so we will get here minus 4. Minus 4 and here plus 4. So denominator is becoming 0. Right? Denominator is becoming 0. This is the failure case. Failure case. Why it is a failure case? Since minus 2 square plus 4 is equal to 0. So we are getting a failure case here, right? Because d square should be replaced with minus 2 square, which is minus 4 plus 4 is becoming 0. Then in the failure case, what we have to do? We have to multiply the numerator with x and differentiate the denominator. The sin 2x will be as it is. Sin 2x will be as it is. We have to multiply the numerator with x and differentiate the denominator with respect to d. Derivative of d square is 2d plus derivative of 4 is 0, right? Derivative of 4 is 0. Now yp equals to, what will happen? Let us see, x by 2, this x by 2 into 1 by d will remain, into 1 by d into sin 2x. What is 1 by d now? Already we have discussed, 1 by 2 is called as inverse operator. If d is the differential operator, then 1 by d is called inverse operator, and it is treated as the integration. 1 by d is treated as integration. Then integration of sin 2x, x by 2. What is integration of sin? Integration of sin is minus cos 2x by derivative of 2x is 2. So integration of sin 2x is minus cos 2x by 2. Therefore what will be the particular integral? Final particular integral will be minus x by 2 to the 4 cos 2x. Right, this is the particular integral. Then what will be the general solution of 1? General solution of the given equation 1 is y equals to yc plus yp. What is yc here? Yc is c1 cos 2x plus c2 sin 2x plus what is yp? Yp is particular integral is minus x by 4 cos 2x. So this is the general solution of given equation, d square plus 4 into y equals to sin 2x. This is the procedure we have to follow in the second case, right? Now we will move towards the third case. We have discussed the second case. Instead of this sign, even if cos is given, the same procedure we have to follow. If cos 2x is given also, we have to follow the same procedure, right? Now we'll move towards the third case, case 3. Okay, let us consider the third case for finding particular integral. In the third case, right hand side function, if the right hand side function is x power m. See, remember first case is e power ax, right? The second case is sine of ax plus b or cos of ax plus b, and the third case now that we are going to discuss is x power m, where m is the positive integer. M is positive integer. It is not negative, it is not 0, it is not It is not fractions. It is the integer which is positive integer, means 1, 2, 3, 4, 5, 6 and so on. X power 1, x power 2, x power 3, x power 4. If it is given in the right hand side, then how to find the particular integral, right? So particular integral is given by 1 by f of d into x, capital X. Capital X is nothing but x power m, because the third case is x power m. So what we have to do for finding particular integral, this f of d should be written in the form of 1 plus phi of d. Right, 1 plus some function of d. This actually f of d nothing but function of d only. This function should be written in the form of 1 plus some function of d. 1 plus some function of d. This, for writing this, what we are doing, we are taking the common. What common we are taking? We are taking that least degree term of d as common. We are taking least degree term of d. Least degree term of d should be taken as common. What is the meaning of least degree term of d? Suppose the f of d is d square plus 3d plus some 2. Then what is the least degree term in this? See, d square, d power 2 is there, d power 1 is there, here d power 0 will be there. So d power 0 is the least degree term. So this term should be taken as common. When we take this term as common, what will remain? 2 into, here 1 will remain. This here 2 is taken out, no, so 1 will remain. 1 plus what will remain? D square plus 3d by 2, right? So this has been reduced into the form of 1 plus function of d, 1 plus function of d. So this is how we have to take the least degree term of d as common to make f of d. This is actually f of d, this is actually f of d. Now this is reduced in the form of 1 plus phi of d, 1 plus some function of d. So this is the procedure that we have to follow in the problems, right? So we have to take the least degree term of d as common to write f of d in the form of 1 plus phi of d. Then what will happen? This 1 by f of d will become 1 by 1 plus phi of d, x power m as it is. Then this 1 plus phi of d can be taken above. When we take this above, we will get minus 1 here, power minus 1 we will get. Now this can be expanded by using binomial expansion. Once we expand this, then we can simplify this. So for expanding this 1 plus x form, it is in the form of 1 plus x, right, power minus 1. So we are having binomial expansions readily available. We are going to use any of these expansions to solve this expression, right? If we get 1 plus x whole power minus 1 form, where x is given by some function of d, if we get 1 plus x whole power minus 1, then the expansion of this is given by 1 minus x plus x square minus x cube plus x power 4 and so on. If we get 1 minus x whole power minus 1, if we get 1 minus x whole power minus 1, then the expansion is 1 plus x square plus x cube plus x power 4 and so on. If we get 1 plus x whole power minus 2, then the expansion is 1 minus 2x plus 3x square minus 4x cube and so on. If we get 1 minus x whole power minus 2, then the expansion is these all minuses will become plus. So 1 plus 2x plus 3x square plus 4x cube and so on. So these are the formulae for expanding this 1 plus phi of d. Right? Now we will see problems related to this case. So let us consider the first problem. Okay, the first question is solve d square minus 3d plus 2 into y equals to 2x square. So this is the given question. It is a second order differential equation with constant coefficients, and it is non-homogeneous because right hand side 2x square is there. So how to solve this? We have to find the complementary function first for this one and then find the particular integral. So for finding complementary function, what we have to do? We have to write the auxiliary equation. You consider the given equation as, 1, then find the auxiliary equation. So auxiliary equation of 1 is, what will be the auxiliary equation? M square minus 3m plus 2 equal to 0. Now solve this. For solving this, m square minus 2m minus m plus 2, factorizing. So further m can be taken out. So what will remain here? M minus 2 minus 1 can be taken out. What will remain? M minus 2 is equal to 0. Now m minus 2 can be taken out. If we take m minus 2 outside, then what will remain? M minus 1 equal to 0. So what will be the roots now? M equals to 1 comma 2. Right, these will be the roots for the given equation. auxiliary equation, the given auxiliary equation. Then if the roots are 1 and 2, then what will be the complementary function? Already we know complementary function is given by yc equals to c1 e power 1x plus c2 e power 2x. So this is the auxiliary equation. This is the auxiliary equation for the given differential equation. Now this is the complementary function for the given equation. Now move for finding particular integral. Now particular integral is given by yp equals to 1 by f of d. F of d is d square minus 3d plus 2 into capital X. Capital X is here 2x square, right? So it is in the form of 2x square is in the form of x power m, that is the third case, x power m. So what we have to do, this f of d should be written as 1 plus some function of d by taking the least degree term of d as common here. What is the least degree term of common in this? D square, second degree, d power 1, first degree, here d power 0 will be there, here d power 0 will be there, d power 0 is 1. So least degree term of d is 2 only. So this 2 should be taken out. Therefore yp equals to, this yp equals to, you can take 2 outside. When we take 2 outside, what will remain? 1. Here 1 will remain, 1 plus d square minus 3d will remain, no, plus d square minus 3d will remain, which is divided with 2 because 2 is taken out, right, into 2x square. Right, 1 plus d square minus 3d by 2. Now this 2 and 2 can be cancelled out. Now it is in the form of 1 plus phi of d. It is in the form of 1 plus phi of d. Now it can be written as 1 plus bracket of d square minus 3d by 2 whole power. You take this in the numerator, whole power minus 1 into x square. It is in the form of 1 plus x whole power minus 1. It is in the form of 1 plus x whole power minus 1, which is equal to 1 minus x plus x square minus x cube plus x power 4 and so on. It is in this form. So this formula can be used now, right? Just now we have noted down 4 formula. Out of that I am going to use this 1 plus phi of d, 1 plus x. So expand this by using this formula, where in place of x what we are having here? In place of x we are having d square minus 3d by 2. So what we will get? Therefore yp equals to 1 minus x, 1 minus x. X is d square minus 3d by 2. This is x. Then plus x square plus what is x square? D square minus 3d by 2 whole square, then minus so on, right? This is the expansion of 1 plus this bracket term into x square. So further we have to simplify this. Yp equals to 1 minus d square by 2 we will get here, d square by 2, then multiply this minus with this minus, so it will become plus 3 by 2 or 3d by 2, right? Plus here, because all these are derivatives, the derivative should be operated on x square. If x square will be surviving, x square will not become 0 unless second derivative is there. See, x square first derivative is x square is there, no? First derivative of x square is 2x. One more derivatives. This is the first derivative. Second derivative of x square is 2. Right? First derivative of x square is 2x. Second derivative of x square is 2. One more derivative if we find, third derivative if we find, then what we will get? Derivative of 2 will become 0. So it is enough for us to have up to second order derivative only. If we consider the third order derivative of x square will become 0. So we don't need to write d cube, d power 4, d power 5 and so on. Hope you are understanding this. If we write d cube, that is the third order derivative of x square is becoming 0. So that term will automatically become 0. We don't need to write d cube, d power 4, those terms we don't need to write. It is enough for us to have only d square terms. See here, a minus b whole square form, a minus b whole square form, a square is d square square, which is d power 4. We don't need to write d power 4 because fourth derivative of x square will automatically becomes 0. We don't need to write that term. Then 2ab. So 2 into d square into 3d. So what we'll get? 6d cube. 6d cube we will get. So d cube also we don't need to write because the third order derivative of x square is becoming 0. Then next b square term, a minus b whole square. In a minus b whole square, b square term is 9d square. So what we'll get here? 9d square by 4, right? 9d square by 4 plus so on. It is enough for us to write only these terms because next terms automatically make x square to be 0, right? Now we have to apply this. We have to apply this on x square. Now apply. What will happen? 1 into x square only as it is. Then minus 1 by 2 into second derivative d square of x square. Second derivative of x square. Second derivative of x square is 2. Second derivative of x square is 2. So we'll get 2 here. We'll get 2. Then next. Then next 3 by 2 plus 3 by 2 of first derivative d, derivative of x square. Derivative of x square is 2x plus 9 by 4 again second derivative of x square, again second derivative of x square. Second derivative of x square is 2, right? Plus so on. So here this 2 and this 2 will get cancelled. Here this 2 and here we will get 2. Then here this 2 and this 2 will also get cancelled. So x square, next x terms, plus 3x, x square plus 3x, here minus 1 and here 9 by 2, plus 9 by 2 minus 1. So little bit simplification will give us x square plus 3x plus what will happen here when you take the LCM of 9 by 2 minus 1, we will get here 2 we will get. So 7 minus 7 by 2 we will get. So particular integral is x square plus 3x plus 7 by 2, right? So what will be the final solution then? Therefore final solution is y equals to yc plus yp. General solution. Yc is c1 e power x plus c2 e power 2x. Then yp is x square plus 3x plus 7 by 2, right? This is the general solution of given equation d square minus 3d plus 2 into y equals to 2x square. So this part I don't need to explain again because it's a complementary function part. Then particular integral once again I am going to explain. See, whenever x power m terms are there, what we have to do? We have to take the least degree term of d as common. Here d square is there, here d power 1 is there, d power 0 is there. Here d power 0, it is the least degree term. So 2 has to be taken out. When we take 2 outside, we will get 1 here and d square minus 3d by 2 we will get here. Then x is 2x square as it is. This 2 and 2 will get cancelled. Now this can be written as power minus 1. It is in the form of 1 plus x whole power minus 1. So expansion is given by this. That expansion I am writing here 1 minus x, x is this one, then plus x square, d square minus 3d by 2 whole square. Now we have to expand this. So we are excluding the terms which will make this x square as 0. See, x square will survive only up to the second derivative. First derivative of x square is 2x, second derivative of x square is 2. If we find the third derivative, it is constant, derivative is 0. So we don't need to consider d cube, d power 4 and so on. We have to consider only up to d square. So that is why here d square by 2 we are getting, here 3d by 2 we are getting here. But here when we expand, a minus b whole square formula when we apply, here we will get d power 4. We don't need to write that. Then 2ab, minus 2ab term. So minus d square, here d cube we will get. That is also need not to consider. Then finally 9d square we have to consider that. So apply these derivatives on x square and simplify, we will get this particular integral. Let us see one more problem in this case. Now the second problem is solve d cube plus 2d square plus d into y equals to e power 2x plus x square plus x, right? So this is a non-homogeneous third order differential equation, linear differential equation with constant coefficients. Right hand side e power 2x plus x square plus x is there. First we have to find the complementary function. That part I am not going to do now because already we have discussed so many times how to find, or else I will do it. Auxiliary equation. First we have to write the auxiliary equation. Auxiliary equation is given by m cube plus 2m square plus m equal to 0, right? M you take common, m when we take common, what will remain here? M square plus 2m plus 1 is equal to 0. Now m into, factorize this, when we factorize this can be written as m plus m, or else directly we can write this as see, it is in the form of a square plus 2ab plus b square. So m plus 1 whole square, it can be written as m plus 1 whole square equal to 0. Now this is nothing but m into m plus 1 into m plus 1 equal to 0. Then roots will be m equal to 0, minus 1 and minus 1. So these are roots, real and repeated roots. Then what will be the auxiliary equation? Y equals to c1 e power 0x plus, because minus 1 is repeated 2 times, so c2 plus c3x e power minus x. So this is y equals to, it is complementary function, yc equals to c1 e power 0 will become 1, c1 into c1 plus c2 plus c3x into e power minus x. This is the complementary function. Now we have to go for particular integral. So this is the complementary function. Now for particular integral yp equal to, what we have to write? 1 by d cube plus 2d square plus d into e power 2x plus x square plus x. So one step ahead, what I am going to do is this d cube plus 2d square plus d, which is nothing but in this form only, can be written as m into m plus 1 whole square, means d into 1 plus d whole square, because when we expand this we are going to get d cube plus 2d square plus d, right? Then e power 2x plus x square plus x as it is. Now you see how many cases are involved here. See, this x square comes under x power m case, x power 1 also comes under x power m case, but this e power 2x comes under first case, e power ax form. So e power ax, when e power ax, let us separate this, e power 2x by d into 1 plus d whole square plus these x square plus x comes under the third case, d into 1 plus d whole square, right? Now this if e power ax is there, what we have to do? This d should be replaced with a. So d should be replaced with 2 now, e power 2x by 2 into 1 plus 2 whole square, first case. Now these two terms are for third case. We have to write in the form of 1 plus phi of d. Already you observe that this is in the form of 1 plus phi of d. So this can be written as 1 by d as it is I am writing, then 1 plus d whole power minus 2 can be written. Then what is remaining here? X square plus x. So it is in the form of 1 plus phi of d. We don't need to take any common here. 1 plus d whole power minus 2. Then here just simplify, e power 2x by, what will happen here? 1 plus 3 is there, 1 plus 2 is there, 1 plus 2 is 3, 3 square is 9, 9 2 is 18. So e power 2x by 18, first term, then plus 1 by d. Now we have to use the formula 1 plus x whole power minus 2, which is 1 plus, so 1 minus 2x plus 3x square minus 4x cube and so on. This formula we have to use now. So use that formula. What we will get here? 1 minus, in place of x we are having, in place of x we are having d here. So 1 minus 2d plus 3d square minus 4d cube plus so on, right, into x square plus x. So now which is equal to e power 2x by 18. Now 1 by d can be taken out, taken inside. When we take this 1 by d inside, what will happen? This into, so 1 by d first, 1 by d into 1 is 1 by d, then minus 2 into d by d is 2 only, right, plus 3 into d square by d is d, minus 4 into d cube by d is d square plus so on, into x square plus x. Now you operate this complete bracket on x square and x. So what will happen? Let us see. This is equal to e power 2x by 18 as it is. Then 1 by d is integration of x square and x. Integration of x square is x cube by 3, integration of x is x square by 2. Then minus this minus 2 into x square, minus 2 into x square, then minus 2 into x plus 3 into derivative of x square. Derivative of x square is 2x and derivative of x is 1, minus 4 into this d square means second derivative. Second derivative of x square is first derivative. See, x square, first derivative is 2x, second derivative is 2. So second derivative is 2 and second derivative of x, first derivative of x is 1, second derivative of x is 0. So 2 plus 0. So these are the terms we are getting. Now simplify this. E power 2x by 18 plus x cube by 3. Here what will happen? You see just this minus 2x square and here x square by 2 is there. You take the LCM of these two. Here we will get minus 4 plus 1 is minus 3 x square by 2. So these two terms are over. Now here minus 2x plus what we will get here 6x we will get. 3 to the 6x minus 2x is plus 4x and here minus, here we will get 3 into 1 is 3 minus 8. Minus 8 plus 3 is minus 5. Right, this is yp. Particular integral also we got. Then what will be the final solution? Then final solution is y equals to yc plus yp. What is yc? c1 plus c2 plus c3x into e power minus x plus yp. Yp is e power 2x by 18 plus x cube by 3 minus 3x square by 2 plus 4x minus 5. This is the required general solution of given equation. So this kind of problems also may be asked in the examination, where right hand side instead of only one type of functions, two types of functions will be given, like e power 2x and x square and x. So e power 2x comes under first case. So for that what we have done, e power 2x by d into 1 plus d whole square is there, no? So the d is replaced with 2. This comes under first case. And for the second case, x square plus x, what we have to do? We have already it is in the form of 1 plus 5 of d. So we have to take in the numerator and apply this formula and simplify. We will get the particular integral. So in today's class, for finding particular integrals, we have seen case 2 and case 3. So case 2 was sine of ax plus b or cos of ax plus b. If right hand side function is sine of ax plus b or cos of ax plus b. And the third case is right hand side function will be in the form of x power m. So two more cases are remaining, fourth case and fifth case. That will be discussed in next class. I am going to end today's session here. See you in the next class. Thank you.